All right, so this is section 6.2, part 1, and we are talking about the volume of prisms and cylinders. So if you can write down these formulas. So the word rectangular is not on your notes outline. You're going to have to add that because we do have two different kinds of prisms we're talking about today. Capital B is not the same thing as lowercase b in these formulas. So capital B equals the area of the base. And we get that by doing length times width. And then H always stands for the height. And V stands for volume. Okay. For a cylinder, which looks like this, like a Pringles can or a can of food or whatever, that's all a cylinder. So area of the base, capital B, is a circle, so it's pi r squared. The height is H, and the volume is the area of the base times the height. And then you have one more to add there. So a triangular prism, which would be like, if you think of it like the roof of a house or something as a triangular prism. Capital B, which is the area of the base, is the same thing as the area of a triangle. So 1/2 base times height. And then the volume would be capital B times the height. So pause your video and write these down. Okay, so the other thing I want to point out during this lesson is you're not going to have to memorize these formulas. I'm going to give you like a little sheet with all the formulas on it. However, on that paper, there are not any pictures. So you do have to understand what these shapes look like. Like you're going to have to look at a shape and know what it is and what formula to use, because I am not giving you like a picture example beside the formula. So you're going to have to know what a cylinder looks like. What does a rectangular prism look like? Okay, and some kids don't realize that until they go to like do the review of the test, that they don't know what these shapes look like.
When's the review?
It'll be like a week from now, week and a half from now. Okay, so the volume, find the volume to the nearest tenth, use 3.14 for pi. So number 1 is a rectangular prism with a base of 2 by 5 and a height of 7. So first of all, is there pi involved with a rectangle? Does a rectangle have anything to do with a circle? No, so this whole part about using pi is not relevant to this particular problem. Okay, so for a rectangular prism, I'm going to calculate capital B, which is area of the base, and I'm going to take length times width.
So 2 times 5.
2 times 5. So my capital B is 10. Okay, then to find the volume, I'm going to take capital B times the height. So 7. So my volume is 70. And then my label is M for meters, and then volume always has to have a little 3 right here, a Q, because volume is 3 dimensions. So you're going to include the 3. Okay, so now the good part about rectangular and triangular prisms is that multiplication is commutative. Does anybody know what that means? Commutative?
Just distributive properties stuff.
No, it means that like you can flip them around and they're going to be the same answer. So like 2 times 5 or 5 times 2 are both going to get you to 10. So the thing is with these, until we get into a cylinder, it doesn't work for a cylinder. But let's say you switch around these numbers and don't put them in the correct order, you're still going to get the same answer in the end, as long as you use all 3 numbers and you only use them one time. Does that make sense? We should all still end up with 70, even if we put the numbers in a different order. Okay. So another rectangular prism with a base of 2 by 5 and a height of 3. So capital B is length times width. So 2 times 5. So again, capital B is 10.
Times
10 times 3. So my volume is 10 times 3. So my volume is 30 centimeters cubed. Okay, number 3. Find the volume of each figure to the nearest tenth, use 3.14 for pi. So this is what I was talking about when I said you have to know what the shape is called. Like there's not a name of what the shape is here, it's just a picture. So you have to know that that's a cylinder by looking at the picture in order to use the correct formula, okay? So for a cylinder, capital B is pi times r squared. So in this case, what is our r? Our r.
3.4. 1.4.
The radius is 6. So capital B equals pi times 6 squared. So what is 6 squared?
36.
36. So 36 times 3.14. Okay, 113.04. So now I need to take that number times the only number I haven't used yet,
1,690.
times 15. And you got what?
I got 1,695.
0.5? 0.6, sorry. And that would be meters cubed. Okay, number 4. Find the volume of the figure to the nearest tenth. And that doesn't have a name with it either. What kind of shape is that? That's a triangular prism. So for capital B, area of the base, I take 1/2 times base times height. So again, there are 3 numbers here. Multiplication is commutative, so technically you don't have to like have a certain number in a certain place if you're not, you don't always have to pick it out correctly to put the same numbers in the same place. Does that make sense? And you're gonna get the same answer. So 1/2 times base. So what number do you think I would use for base?
7.
That would be my height. So I'm looking at this right here.
7.
That's my height.
4.
So 4 times 7. But either way, we would get the same answer. So 1/2 times 28 would be what?
14.
14. Okay, so then for my volume, I'm taking 14 times the number I have not used yet.
11.
11.
32.
What do you get?
132.
154 feet cubed. Okay, so I want you guys to try this number 5 on your own. So you'll have to pause your video and work through number 5.
It's a 0.
Okay, so for capital B, you will take pi times 4 squared. So that is 16 times 3.14, which is 50.24. And then I'm taking 50.24 times 12. So your volume is 602.9, if you round, inches cubed. Okay, so I would like you to go through number 6 and try that. It is what kind of shape?
Oh,
Triangular prism. Okay, guys. let's go over this one. So don't erase your answers if you have put your different numbers. If you put your numbers in a different place, you should still end up with the same answer. So 1/2 times, I'm gonna do 6 times 5. So that is 1/2 times 30, which is 15. And then for my volume, I'm taking 15 times the number I have not used yet, which is 7. And I'm going to get 105 feet cubed.
So if you put a 7 there instead of 600, let's say it's 7.
I think,
Should still get 105.
how did you, I got 350.
Did you do the half?
Yeah, I did
Then I still
that.
got 17.5.
I don't know.
Put 7
Then you
there.
times it by half.
It's
You have to
7.5.
times, so you do 5 times
Did you
6.
times it by half?
Yes.
Yeah. I have 17.5.
All right, so for the next one, we are going to compare the dimensions if we change them. So a cereal box measures 6 by 2 by 9. So this doesn't have any labels with it. What do they usually go, how do they usually go in order? Like something by something by something.
Length times width.
Length times width times height. Okay, so explain whether doubling the length, width, or height would double the amount of cereal the box holds. So if we change the dimensions of the box, would that change the volume of the box? So let's look at the original dimensions. So capital B equals length times width. So 6 times 2. So 12. And then my volume is 12 times the number I have not used yet. So what would that be? 9. So 12 times 9 is 108. And these are inches cubed. Okay, the next one is doubling the length and see what happens. So what would our new length be?
24.
We're just doubling the length.
24.
So just 12, because we're taking 6 times 2. So for capital B, I would take 12 times
2.
2.
And then you do 24.
So then you would get 24. And then my volume, I'm going to take 24 times the number I haven't used yet. So 9.
2.
Okay, 216 inches cubed.
Dude, that's gonna be super tall.
Yes. Okay, so now if we double the width, so what's the new width going to be?
4.
4. So capital B equals length times width. So you're going back to the original, so 6 times 4. So if capital B equals 24, what's the volume going to be?
216.
216 again. Okay, so now we need to double the height. So our new height is going to be 18. So we didn't change the length or the width, so we can go back to the original area of the base. So capital B would equal 12. So my volume would be 12 times 18.
Which is the same.
216.
Which is 216 again.
So then it would double.
Okay, so our volume doubled. Does it matter which dimension we double?
No.
All the volumes are the same. So then the, cereal company like Kellogg or something like that has to decide what's easiest to ship, what's easiest for the grocery stores to put on their shelves, that type of thing to decide how to change the box.
What about customers? What's easier to store for the customers?
Right. So doubling the height
That's
probably is not the best idea, right? What do they usually double?
the width.
The width.
Width.
So you would usually have just a wider box instead of like a lot taller of a box.
Like family size?
Yeah, like family size. Sometimes Sometimes family size is a little bit taller, but it's not like double a regular box of cereal. That would be ridiculously tall, and it wouldn't fit on a grocery store shelf or like a pantry shelf at your house. It wouldn't fit. Okay, so those are things companies have to think about. All right, number 8, a can of corn has a radius of 2.5 and a height of 4. So what kind of shape are we talking about?
Cylinder.
Cylinder. Can of vegetables would be a cylinder. Explain whether doubling the height of the can would have the same effect as doubling the radius. So let's look at the original dimensions first. So capital B equals pi times 2.5 squared. And I would use 3.14 for pi.
6.2.
So 3.14 times 6.25. What does that equal?
Where'd you get the 6.25?
2.5 squared. So I get 19.625. Anybody else get that?
19, yeah. I did.
Okay, so now I'm gonna take that times what number?
4.
Times the height, which is 4. And you get what? 78.5. Okay, now if we double the height of the can, what's the new height gonna be?
4.
Oh,
Wait,
8. Okay, so if all we did was double the height, is capital B gonna change?
no.
No, capital B is still going to equal 19.625. So take that times 8. Okay. So now let's double the radius. What's our new radius? 5. So capital B is going to equal 3.14 times 5 squared. So 5 squared is 25 times 3.14. What's that?
78.5.
Okay. So then for my volume, I'm going to take 78.5 times what number?
4.
4. Back to my original height.
314.
Okay. So which one would give you the most volume? Doubling the radius. Which would make sense because if you ever go to like Sam's Club and buy, or you don't necessarily buy it, but those like big giant cans of corn or green beans or whatever, they're not just like the same size can but really super tall. They're like a wider can. They're a little taller too, but they're really wide. And that's because it has the most volume, and which would make more sense to make the one with the most volume if you're trying to ship something in bulk. Okay, so we are going to skip this last one, and I would like you to start on your homework. I would like you to label this at the top, page 270, and it's assignment number 1, because you're going to have a page 270 assignment tomorrow also.
We only have 8 problems.